All right, we're looking at the equations in y equals mx form. This is going to be part 2. So this is a continuation from yesterday's packet. So if you did not get yesterday's notes done, you need to get that done first. Okay, so you should be on the page where the key concept is compare direct variations. Okay, so in the last section, you learned about direct variations, and now we're going to take a look at comparing direct variations. So if you read along with me, it says, you can use tables, graphs, words, or equations to represent and compare proportional relationships. Okay, so we have a table here. It's a proportional relationship. If you were to do, to divide 3 divided by 15, 4 divided by 20, 5 divided by 25, you would get the same number over and over. That means it's proportional. If we look at the graph, it goes through the origin. Okay, pardon my horrible writing, let's try that. Passes through the origin. Much better. With words, y varies directly with x, and in an equation you would look like this. With our equation, you have a y on one side equals a coefficient and an x. Our coefficient is 1/5 because if I took this number and made it into a fraction 3/15, that would simplify to 1/5. So that's where the 1/5 comes from. Okay, just a little note to think about, to stop and reflect. In a proportional relationship, how is the unit rate represented on a graph? Explain below. Okay, so in just a second, you're going to see one of the gray boxes that asks the question, and you're actually going to answer this question. But I want to talk about it for just a second. Read through it with me one more time. In a proportional relationship, how is the unit rate represented on a graph? Here's what they mean. Our unit rate is 1/5. It's 1y for every 5 x's. Okay? Take a look at our line. If you were to take and find where does 1 in the 5, can the 1 in the 5 be represented or found on this line? So if you look at this line, how can you see a 1 and a 5 as the rate? Remember, a rate is like a pattern. It's how things increase. So think about how that could possibly happen. Okay, so on this page, you are going to answer that stop and reflect question. So take a look at what's our unit rate. Our unit rate was 1/5. Think about other times you've seen that fraction and what you do with that fraction on a line. Think about it and see if you can come up with an answer. Okay, let's take a look at an example. Number 3, the distance y in miles covered by a rabbit in x hours can be represented by the equation y equals 35x. The distance covered by a grizzly bear is shown on the graph. Which animal is faster? So we have two different things happening. With the rabbit, we were only given an equation. The grizzly bear is the one that's on the graph. So the rabbit is not on the graph. The grizzly bear is on the graph. Okay. So we have two situations here. We have one written as an equation, one written as a graph. You have some choices. If you had this situation, you could graph both and compare. You could write both as a rise over run and compare. Okay. So let's take a look. What if we wanted to put the rabbit on the graph? Oops, that meant to be the eraser. Let's put the rabbit on the graph. Now the rabbit, for every hour, it goes y miles. So if I wanted to make a table, I could. So x would be hours, y would be miles for the rabbit. So if the rabbit's going running for 1 hour, he's gone 35 miles. And the reason I know that is because of this equation. If I replace the x with a 1, I get y equals 35. If I replace the x with a 2, y is 70. X with a 3, y is 105. So if we went and graphed that, I'm going to do my best to plot everything where it needs to go. I'm a little bit off just because of my pen. Okay, so what you might notice is my graph is just a little bit steeper. It's going to start at 0, 0, just like the other. So I'm going to have a little bit steeper. Okay, so the rabbit is faster. Okay, so if you wanted to compare them both on a graph, you could do that. Sometimes it's a little tricky. This graph, I'm really close to each other, so any error could have caused a problem. Okay, however, another option we could have done was we could have looked at the slope. Okay, and what you have learned up to this point is 35, the number that's the coefficient of the x, is the slope. Okay, so that number that's the coefficient of the x tells you how steep or flat your line will go. So if I compare, the grizzly bear is 30 over 1, the rabbit is 35 over 1. For every 1 hour, 35 miles. 35 is larger than 30, so it's faster. 35 miles per hour is faster than 30 miles per hour. So either way, you could have determined this number, or which is faster. So in your notes, definitely either show in the graph that they're different, or show with words. All right, sorry about that. Okay, so let's take a look at C, the got it. Now it's important, I'm noticing a lot of people are not completing these sections. It is very important that you complete these sections. This is the practice that we do together to prepare you for the independent practice. So let's take a look at this problem. Financial literacy. Damon's earnings for 4 weeks from a part-time job are shown in the table. Assume that his earnings vary directly with the number of hours worked. Okay, so I want you to stop for a second. Look at the wording that they have here. Assume that his earnings vary directly with the number of hours worked. The way they're wording this will help you understand what this direct variation even means. Okay, there's a lot of these words that we're getting thrown around right now, and they do mean something, and the words that are chosen very carefully in hopes that it makes sense when put in a sentence like this. Assume that his earnings vary directly with the number of hours worked. This is what this means. There's a relationship between what he makes and how many hours he works. Let's think about that in real life. Would you ever go to a job that says, I don't know, we're going to pay you like whatever? It happens, but that's not normal. Okay, a normal job that you go to that's like legit is going to have a pay per hour. Okay, your earnings is going to vary directly with the hours you work. So if you work for 1 hour, you're going to get, say you make $10 an hour. If you work for 1 hour, you're getting $10 for that hour. If you work 3 hours, you're getting $30 for working those 3 hours. The earnings are directly correlated and vary directly with the number of hours you worked. Okay, we're not talking side job. We're talking like normal job in real life. Things vary directly with each other. Okay, the time it takes me to get somewhere varies directly with the speed that I'm going on my trip. Okay, so this direct variation is just saying that there's a consistent relationship happening. Okay, so if we look at our example here, the time he worked is H. The total pay is representing our Y. Anytime you see a total, we're always assuming it's the Y. Okay. He can take a job that will pay him $7.35 per hour. Which job has a better pay? Okay, so this is job A, and this is job B. We want to see which job is better. So for job B, they gave us our rate of pay was $7.35 per hour, or for 1 hour. Okay, let's look at our information up top. I don't know how much per hour. I know how much for 15 hours. I know how much for 12 hours. I know how much for 22, and I know how much for 9. Okay, we can take that information and come up with a per hour. So if it's $112.50 for 15 hours, I can come up with how much for 1 hour. I just take $112.50 divide by 15. So we're just using some fraction skills. $112.50 divided by 15 hours means that it's 7.5. So he makes $7.50 for 1 hour with job A, and $7.35 for job B. Which job pays better? You decide. Show some sort of work. Okay, the work that I listed here is very, very close to what you should do. Your only other option could have been, and I'll do this in blue, if you didn't want to do it the way I did it, what you could have done is you could have taken job B and created a similar table. So if I look at this and say, well, for job A, for 15 hours, he made $112. I could say for job B, for 15 hours, he makes, well, $7.35 per hour. So I could take the hours and I could multiply by $7.35. And I would say that job B, he's going to make $110.25. In job A, he made $112.50. Which job was better? Okay, so you have two options of how you wanted to do this. Do you want to convert job B into the same type of presentation as A? Or do you want to take job A and convert it into the same type of information as B? So answer your question, show some work. And it says explain. So tell me why you chose the job you chose, A or B. All right, example 4. A 3-year-old dog is often considered to be 21 in human years. Assume that the equivalent age in human years Y varies directly with its age as a dog X. Write and solve a direct variation equation to find to find the human year age of a dog that is 6 years old. Let X represents the dog's actual age and Y represent the human equivalent. Okay, so we've always heard dog years. So they're saying if the dog is 3 years old in normal time, it's very similar to being 21 years old in human years. Okay, so let's look and see what they did here. We're going to take this first little section. Y equals mx. This is our direct variation. That's our basic formula. This is what we came up with on the first page of this packet. Okay, it was that we derived a formula. Now, Y is human years, X is dog years. Okay, so that's why the Y gets replaced with a 21 and the X gets replaced with a 3. Okay, because Y is human years, X is dog years. Then we're going to simplify. The way we simplified here, just in case you need a little clarification, we had 21 equals M times 3. I want to know just M, so I'm going to divide each side by 3. I divide because my 3's here will cancel. 21 over 3 is 7. 7 equals M. So just in case you need a little reminder of solving equations, that's old stuff at this point. But you would end up with M equaling 7. So what we did here was, since M equaled 7, I took this 7 and I substituted in. And that gets me Y equals 7x. So that's where the Y equals 7x comes from. That is our formula that would help us determine age no matter how many years you're given. You could be given the human years and find out the dog. You could be given the dog years to find out the human. Okay, so let's take a look at them doing that right here. You want to know the human year age or Y value when the dog is 6 years old. So we take our equation right here, and dog years are X. Okay, so X are the dog years. So if my dog is 6 years old, I'm going to substitute my X with a 6. 7 times 6 is 42. So if your dog is 6 years old, he should be 42 years old comparably, like health-wise and how they feel and how they act. 42. So like super old. I hope you got that joke. 42 is not super old. Anyway, so when a dog is 6 years old, the equivalent age in human years is 42. So to check that, we can graph our equation and take a look and say, well, at 0, when the dog isn't even alive, it's going to be the same as a human not being alive. We do know that after 3 years, he's 21 years old, so you'll see the little point right about there. Okay, and then we determine that at 6 years old, a dog is like 42. Okay, and if you connect these dots, they make a straight line, so we know that we're correct. All right, then we need to have 3 points. You can connect them up to a straight line and check yourself. Okay, now there's a couple questions for you. There should be room on the sidebar underneath our cute little fluffy puppy right here. 3 things you're going to write. First one, I know this situation is a direct variation because. How do you know this is a direct variation? What about what's happening here tells you that? Number 2, if a dog is 6 years old, the equivalent age in human years is blank. This should be a no-brainer, by the way. We just did it together, me and you. The human year age of a dog that's 14 years old would be blank. So if you have a dog and you want to say, and somebody says, oh, the human age of this dog is 14. How old is the dog actually? Okay, so that's what we're asking here. We're not asking for if there's a 14-year-old dog, how old is he in human years? I'm saying, hey, your dog is 14 in human years. You tell me how old the dog actually is, like in dog years. So off to the side, remember you're writing that whole entire sentence and you're filling in the blank. Okay, don't just write the answer on the blank because then you're going to look back at it later and have no idea what you did. Write the whole statement out with your answer included. Pause it here because we're moving on. Oh, let's try it again. Nope, that's wrong. Hold on. There we go. This is what I want. Sorry about that. Okay, so let's do 2 problems just to see if you got it. D is our first one. A charter bus travels 210 miles in 3.5 hours. Assume the distance traveled is directly proportional to the time traveled. Write and solve a direct variation equation to find out how far the bus traveled in 6 hours. Okay, so down below here. Now, if you don't have room on your paper, you're going to need to do this in your notebook. But let's split up our area down below. So D, charter bus goes 210 miles in 3.5 hours. Assume the distance traveled is directly proportional to the time traveled. That means there's a consistent speed. Okay, that means we're not all over the place. We're not going to go 60 miles an hour in 1 minute and 90 miles an hour in another minute. There's something called cruise control that you can put on your car, and it just keeps the same speed the whole way. So we're pretending that this bus is in cruise control. 210 miles in 3.5 hours. How many miles in 6 hours? That's what we want to know. Okay. First thing to do, we need to figure out how far it goes in 1 hour. Okay. If we can figure out how far it goes in 1 hour, so we're going to take this ratio of 210 miles in 3.5 hours, and we're going to come up with how many miles in 1 hour. Because if I can figure out how many miles in 1 hour, I can figure out how many miles in 6 hours. Okay. Let me make this look like a 3. All right. So our best way to figure out the unit rate, we have 210 over 3.5. I know it's weird to have a decimal and a fraction, but let's just go with it for now. Best bet to get a unit rate is to divide. And the reason I say that is because, let's think this through for a second. I want 3.5 to become a 1. If I take 3.5 divided by itself, any number divided by itself equals 1. So if I divide my denominator by 3.5, I divide my numerator by 3.5. Okay? So 210 divided by 3.5 equals 60. So this bus drives 60 miles in 1 hour. Okay. If it drives 60 miles in 1 hour, how many in 6 hours? To get there, if I say, and we're just adjusting fractions, we're not changing the value, we're finding equivalent fractions, okay? Changing the numbers, but keeping the value the same. 1 times 6 is 6, so 60 times 6 is going to get me my distance in 6 hours. 360 miles in 6 hours. Okay. Now, just a side note, so that everybody's clear, on a notebook check, this work over here is going to be required. Just writing this part, not enough. Okay, that's going to get you a pat on the back for copying down the answers that I put in the video. Part of this process is as you write down these problems with me, your brain is registering what's happening, and that's how you learn. So it's very important that you are copying these examples down. Okay, let's look at E. A monarch butterfly can fly 93 miles in 15 hours. Okay. And you have to decide where you're going to put all this if there's no room. So 93 miles in 15 hours. Assume the distance traveled is directly proportional to the time traveled. Write and solve a direct variation equation to find how far the monarch butterfly traveled in 24 hours. So if I know how many miles in 15 hours, if I can figure out how many miles in 1 hour, it will be very easy for me to figure out how many miles in 24 hours. Okay, again, just like the last problem, we can go through and do a progression of equivalency. So I could say, well, if I divide 15 by 15, that gets me 1. 1 times 24 gets me 24. If I do that same problem, remember, it's like a fraction. If you divide the numerator by 2, you divide the denominator by 2. If you divide the left side by 2, you divide the right side by 2. Same type of thing. If I divide 15 by 15, I have to divide 93 by 15. Okay, 93 divided by 15 is 6.2. So my butterfly goes 6.2 miles in 1 hour. Now I'm multiplying 1 times 24 to get my 24 hours, so I'm going to multiply 6.2 times 24. And I'm going to get 148.8 miles in 24 hours. So we're just we're taking the rate that we're given, creating a unit rate, and taking that unit rate and coming up with our final rate. All we're doing really is creating a table and filling the table out with what we need. Okay, if I were to make a table out of this, okay, X is my time, Y is my miles. I'm saying, well, I have 93 in 15. I want to know how much for 1, question. I want to know how much for 24, question. Them telling us that we have a direct variation, that means whatever pattern is happening in my first situation is the same pattern that's going to happen every time. 15 times 6.2 gets me 93, so 1 times 6.2, 24 times 6.2. All we're doing is creating a table knowing that the first situation is the pattern. Usually you need a couple to find the pattern, but now we're telling you have a pattern. That's all that's happening. That's not what I want. Okay. So vocabulary. Make sure you have these 3 words somewhere in your vocabulary page, whether you make your own page for this whole unit or you made a page just for the week. Then we're going to take a look at our guided practice. All right. Number 1. A color printer can print 36 pages in 3 minutes and 108 pages in 9 minutes. If the number of pages varies directly with the time, at what rate is the color printer printing? So, we'll try a table on this one. Okay, so X is usually the time, 36 pages. Okay, so 3 minutes, 36 pages. 9 minutes, 108 pages. Just a reminder, usually the X is the time. Anything per, pages per minute, hours or distance per hour, miles per hour. Whatever's after the per is usually the X, because that first number is our total. Total miles per hour. Okay, anytime you get the total, that's usually the Y, just in case you're struggling with figuring out what's the X and what's the Y. Okay, so we know it's 36 and 3 and 108 and 9. If the number of pages varies directly with the time, that means that the pattern you see here from 3 to 36 and 9 to 108 is the consistent pattern. At what rate is the color printer printing? So when they say at what rate, they just mean they want a unit rate. So that means at 1 minute, how many pages are being printed? So if I come up with my pattern here, I find that if I take my X and I multiply it by 12, I get my y. Or if I rewrite that correctly, y equals 12x. That would be our, let me get a better blue. That would be our equation. Okay, it's not asking you to write an equation, but if we take a look and see what's happening here, the x is being multiplied by, the x is being multiplied by 12, and that's giving us our total, which is y. So for my unit rate, okay, 12 times 1 would be 12. Okay, so we end up with a unit rate is 12 pages per minute. All right, I want you to take a look at 2 and try it on your own. Okay, so let's take a look at number 2 and what happened here. I have all the work up. Let me walk you through it. For A, what I did was I took my equation y equals 32x and I created a table right down here. And I had gallons for my x values, miles for my y's. If you're unsure, remember the total, it tells us the car can travel a total of 288 miles. Okay, usually miles per gallon. So gallon is the x, miles is the y. If you look over at the graph, the gallons are on the x-axis, distance is on the mile, or miles are on the y-axis. So I created a table. I used the 288 miles on 9 gallons in my table, and then I started just picking numbers for x. So I picked a 1 for the x, and when I inserted a 1, I got 32 for the y. So I plug a 1 in for there, substitute a 1 into the x, 32 times 1 is 32. Then I substituted a 2 into the x, 32 times 2 is 64. 0, 0. And I plotted my points as best I could, and it creates a straight line. B. How many miles per gallon does the car get? Okay, so all they're asking is they're asking you for a unit rate. And anytime you have the unit rate, the x value will be a 1. So it's how many miles does this car get for 1 gallon of gas? Okay, and I actually had that in my table. You'll see it circled in red. So this was my unit rate. Okay, what you'll start noticing about unit rates, especially in these type of equations, do you see my unit rate is 32 miles per gallon, and in my equation it's 32x? 32 times x is 32 per gallon. Okay. And then C says the distance traveled by a hybrid using x gallons of gas can be represented by y equals 42x. Which car gets better gas mileage? Explain. So I found the unit rate of the original problem. Now I need to find the unit rate of my new situation, my hybrid car. So I took the formula, or the equation, y equals 42x, and I knew for a unit rate, x would have to be 1, because that's per gallon, okay? And x are my gallons. So per gallon would be 1 gallon. So I substituted a 1 into the x value in my equation. 42 times 1 is 42. So that means if I have 1 gallon of gas, my car can go 42 miles. Then I look and say 32 miles per gallon for A versus 42 miles per gallon for C. 42 miles per gallon wins. So the hybrid car gets better gas mileage. Okay. All right, so I skipped number 3, but I want you to still complete that on your own. Ask me a question if you're unsure about anything. I want you to try that by yourself. And let's head over to number 4. The height of a widescreen television varies directly with its width. A television screen that is 60 centimeters wide and 33.75 centimeters high. Write and solve a direct variation equation to find the height of a television screen that is 90 centimeters wide. So we're going to take 60 centimeters wide by 33.75 centimeters high. Okay, and then we're going to find if it's 90 centimeters wide, how high? We have a couple options. We can take the 60 centimeters wide, 33.75 centimeters high, and we could come up with our unit rate. So we would say if it's 60 centimeters high, and the h is not a variable, that's just telling me it's high, by 33.75 wide. Okay. I want this, if I can make this 1 centimeter high, that gives me some sort of unit rate that I can use. So 60 divided by 60 gets me 1. So 33.75 divided by 60 gives me 0.56. So again, all I did to get the unit rate, I needed the 60 to become a 1, so I divided by 60. Divided the numerator by 60 and my denominator by 60. Okay? And I got, for every centimeter high, it's 0.56 wide. So I can relate that over to this situation. So 1 times 90 gets me my 90 centimeters high. So I'm going to multiply 0.56 by 90. Okay? And that's an x multiplication x, not a variable x. So when I multiply 0.56 by 90, I get 50.4. So if you have a TV that is 90 centimeters wide, it's going to be 50.4 centimeters high. And the reason this is when it says directly varies directly, that just means that there is a system, there is a general rule for sizes of widescreen TVs, and that pattern needs to be followed. There's a ratio that is expected and that can be assumed for every widescreen TV. You're not going to go into Target and see widescreen TVs where one's like super long and one's more square. They all have the same ratio. Okay, just depends on the, if you see a 45-inch TV, it's actually a diagonal, but what you'll notice is there is a ratio from height to width that's consistent. Okay, so 90 centimeters wide, 50.4 centimeters high. Okay, and number 5, this is something you have to do on your own, building the essential question. What is the relationship among the unit rate, slope, constant rate of change of a proportional relationship? So we've talked about these 3 things. They're kind of interchangeable, but each has a little bit of a unique twist. So think about unit rate compared to slope compared to constant rate. They definitely coordinate together. Is there any difference between them? Is there any subtle thing that you can kind of decipher them from, or are they all talking about the same thing? So come up with a relationship that you see between those 3 words, and that's it. You are done.